Alright guys, let's go ahead and take a look at these friction notes. So let's ask ourselves, what is friction? Well, friction is a force between two surfaces that are sliding or trying to slide across one another. For example, when you try to push a toy car along the floor, or if you try to ride your bike on the street. There's also friction when you try to walk between your shoes and the floor. Friction always works in the direction opposite from the direction the object is moving or the direction the object is trying to move. It will always slow a moving object down.
So here's a picture of me on a bike back in the day. I'm moving to the right, so therefore I'm going to have friction pointed in the opposite direction, back to left. Another important thing to note about friction is that the amount of friction is going to depend on the materials from which those two surfaces are made. So for instance, a rougher surface is going to have more friction. For example, you would have to push a book harder to get it moving on a carpet than you would on a wooden floor. This is because there's more friction between the carpet and the book than there is between the wood and the book. Think back to when you were a kid, right? And you were playing around with your siblings and your siblings would drag you on the carpet. Well, if they dragged you on the carpet, it kind of hurt because there's so much friction there. You're generating so much heat. You may have actually got what we used to call carpet burns. But if they were dragging you on ice, it wouldn't hurt because ice produces a very low friction. Let's talk about how those different values of friction can occur. Well, rougher surfaces are going to produce more friction, and the reason being is that they have a bigger mu. And mu is just a fancy way of saying the coefficient of friction. So mu just explains how easily objects can slide on surfaces. The bigger the mu value, the harder it is to slide, and the bigger the force of friction will be. So all we're saying right there is that the more force friction we have, the harder it is to slide. The reason we have more force friction is because we have a big mu value. And again, mu is just telling us how easy or difficult it is to slide two objects or two surfaces together. The smaller the mu, the easier it is to slide, and the smaller the force of friction. A force friction that is tiny is the result of a tiny mu. Something important to note is that friction can also produce heat. For example, if you were to rub your hands together quickly, they get warmer. Take a second right now during this video and do that. Rub your hands together. And then after you rub them together for a few seconds, right, touch your face. You'll feel that your hands are now warm. Probably should have told you to wash your hands before this because let's be honest, your hands are probably dirty, but you get the picture. So maybe now go wash your hands and your face. Theoretically, if you could rub your hands together super fast, you could potentially create fire. I mean, I'm sure there's a superhero that some of you guys have heard of called the Flash, who's able to rub his hands so fast together that he can generate a fire. So friction's kind of funny because it's really useful, but it's also really annoying at the same time. Friction can be a useful force because it prevents our shoes from slipping on the pavement when we walk, and it stops car tires from skidding on the road when they try to brake. So it allows us to slow things down and to stop things. It also kind of stinks because on the flip side, it makes it harder to start moving objects. Let's think about ice for a second. So as the weather's getting colder, I know a lot of you guys are thinking, when are we going to have snow? When are we going to have ice? I want to go out there. I want to go sledding. Well, I'm glad you asked because now we can talk about that. Ice is going to cause very little friction, which is why it's easy to slip over on an icy day. But this is a good thing for ice skating and sledding. So in the case of you walking home from school, it's kind of a bad thing because you don't want to trip and fall. But if you were an ice skater or you went sledding, this would be an awesome thing because now it means that you can move quicker when you're skating and move faster when you're sledding. In physics, ice is going to have a very, very small mu value. And like we said before, a small mu or coefficient of friction is going to result in a tiny force friction. A smaller force of friction just means that it's going to have a harder time slowing you down. A bigger force of friction means that it's going to slow you down very easily. Let's take a look at some of those mu values that we were talking about. So again, mu just meaning the coefficient of friction. And if we look at our chart over here to the left, we're going to notice that we have quite a few on here. We have steel on steel, aluminum on steel, copper on steel, rubber on concrete, wood on wood, glass on glass, waxed wood on wet snow, waxed wood on dry snow, so on and so forth. So some of these surfaces are a little odd, but some of these other surfaces might actually look familiar to you. Taking a look at our questions on the side, we see what surface would create the biggest force of friction? Well, the biggest force of friction is going to result from the biggest mu value. So if I look on my right side of this table, I see that the biggest mu value is 0.8. And that 0.8 is a result of rubber on concrete. Rubber on concrete. Why does that sound so familiar? Well, our tires in our cars are made out of rubber, and the roads are made out of concrete. So it makes sense that rubber on concrete is going to have one of the higher coefficients of friction because that's what we use in our cars to stop. Why would we want a high coefficient of friction for our cars? Obviously, it's for safety reasons. Having a high coefficient of friction means that we're going to have a high force friction, which means that our cars are going to be able to slow down a lot easier. This is just for safety. We want to make sure that when we're in our cars, we're able to stop very quickly and not get in any accidents. So we just talked about how rubber on concrete has a coefficient of friction of 0.8. But did you know that rubber on wet concrete has a coefficient of friction of 0.4? So half the value. Why is this important? Well, when it's raining outside, that concrete gets wet. And if that concrete's getting wet, our coefficient of friction is getting smaller. A smaller coefficient of friction means a smaller force friction, which means it's going to take more time for that car to slow down, which is exactly why when the weather is bad and it's snowing or it's raining and that road is getting wet, we want to make sure that we are increasing our following distance so that we have enough time to slow the car down and stop before we get into an accident. So taking a look at the second question, what surface would create the smallest force of friction? I see that the smallest force of friction would be a result of the smallest coefficient of friction, which is 0.003, and that's from synovial joints in humans. Synovial joints. Some of you may not know what that means, and that's fine, but we can see that it says in humans. So that's just talking about the joints in us. So what would happen possibly if that coefficient of friction in those joints went up? So say instead of it being 0.003, it went up to 0.1. Well, that's actually a disease that some people have, and it's called arthritis. So when the coefficient of friction in the synovial joints is bigger than that value, that means that you have arthritis, which means that it's difficult to move those joints around, unfortunately. Key takeaways from today's notes is that force friction depends on a value called mu. Key takeaways from today's notes is that force friction depends on something called mu, and mu just stands for the coefficient of friction. The smaller the coefficient of friction, the smaller the force friction will be. The bigger the coefficient of friction, the bigger force friction will be. A big force friction means that we're able to stop very quickly. A small force friction means that it's going to take a lot longer for us to stop. This is important, especially when it comes to cars. Like we saw before on our table, rubber on concrete has a coefficient of friction of 0.8, meaning that we'll be able to stop very quickly. But rubber on wet concrete is around 0.4, which means that we're going to need a lot more time to slow that car down. So here we can see the real world application of physics and how it keeps us safe in our everyday lives.